Hello students, in the previous session we studied about the distance formula and the section formula in 3-dimensional space. Here we shall look into some more interesting problems about the section formula. Find the ratio in which the join of point A 2, 1, 5 and B 3, 4, 3 is divided by the plane 2x plus 2y minus 2z is equal to 1. Also, find the coordinates of the point of division. Now, look into the solution. Suppose the plane 2x plus 2y minus 2z is equal to 1 divides the line joining the points A 2, 1, 5 and B 3, 4, 3 at a point C in the ratio of k is to 1. Then the coordinates of C are 3k plus 2 upon k plus 1, 4k plus 1 upon k plus 1, 3k plus 5 upon k plus 1. Take this expression as first expression. Since point C lies on the plane 2x plus 2y minus 2z is equal to 1, therefore, coordinates of C must satisfy the equation of the plane, that is 2 into 3k plus 2 upon k plus 1 plus 2 into 4k plus 1 upon k plus 1 minus 2 into 3k plus 5 upon k plus 1 is equal to 1, which on solving gives us 8k minus 4 is equal to k plus 1, that is 7k is equal to 5 or k is equal to 5 upon 7. So, the required ratio is 5 upon 7 is to 1 or 5 is to 7. Putting k is equal to 5 upon 7 in first expression, the coordinates of the point C of division are 29 upon 12, 9 upon 4, 25 upon 6. Let us look into one more interesting example here. Vertices of a parallelogram ABCD are A 3, minus 1, 2, B 1, 2, minus 4 and C minus 1, 1, 2. Find the coordinates of the fourth vertex. Look into the solution here. Let the coordinates of the fourth vertex D be x, y, z. Since diagonals of a parallelogram bisect each other, the midpoints of diagonals, namely AC and BD, should coincide. So, 3 minus 1 upon 2, minus 1 plus 1 upon 2, 2 plus 2 upon 2 will be equal to 1 plus x upon 2, 2 plus y upon 2, minus 4 plus z upon 2. Now, what we do is we equate the coordinates of x, y and z respectively. We have here 1, 0, 2 that is equal to x plus 1 upon 2, y plus 2 upon 2 and z minus 4 upon 2. On equating, we have here x plus 1 upon 2 is equal to 1, y plus 2 upon 2 is equal to 0, z minus 4 upon 2 is equal to 2, which on solving gives us the value of x as 1, y is equal to minus 2 and z is equal to 8. Hence, the coordinates of the fourth vertex are 1, minus 2, 8. We have one more example here. If the origin is the centroid of the triangle with vertices P 2a, 2, 6, q minus 4 comma 3b comma minus 10 and r 8 comma 14 comma 2c, find the values of a, b and c. As we know, what is a centroid? It is a point where all the three medians of a triangle meet. So, the coordinates of the centroid of a triangle PQR are 2a minus 4 plus 8 upon 3, comma 2 plus 3b plus 14 upon 3, comma 6 minus 10 plus 2c upon 3, that is 2a plus 4 upon 3, comma 3b plus 16 upon 3, comma 2c minus 4 upon 3. It is given that the origin is the centroid of the triangle PQR. So, what do we do here? We equate the coordinates of x, y and z and we get 2a plus 4 is equal to 0, 16 plus 3b also is equal to 0 and 2c minus 4 is equal to 0, which on solving gives us the value of a as negative 2, b as minus 16 upon 3 and c is equal to 2. Let us look into one more example here. Find the lengths of the medians of the triangle with vertices a 0, 0, 6, b 0, 4, 0 and c 6, 0, 0. Let D, E and F be the midpoints of the sides BC, CA and AB respectively. As we know, the medians divide the side on which they fall. So, the coordinates of D, E and F can be found out by using the formula x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 upon 2. So, point D can be calculated as 0 plus 6 upon 2, comma 4 plus 0 upon 2, comma 0 plus 0 upon 2, that is equal to 3 comma 2 comma 0. Similarly, we can calculate the coordinates of point E as 6 plus 0 upon 2, comma 0 plus 0 upon 2, comma 0 plus 6 upon 2, that gives us 3 comma 0 comma 3, and the coordinates of point F can be calculated in the similar manner as 0 plus 0 upon 2, comma 0 plus 4 upon 2, comma 6 plus 0 upon 2, that is equal to 0 comma 2 comma 3 respectively. You can see in the figure the triangle with points A, B and C and also with the midpoints as D, E and F. Now, we also will calculate the length of the medians, namely AD, using distance formula, that is square root of 0 minus 3 whole square plus 0 minus 2 whole square plus 6 minus 0 whole square, that is equal to square root of 9 plus 4 plus 36 is equal to 7. Same way, BE is equal to square root of 0 minus 3 whole square plus 4 minus 0 whole square plus 0 minus 3 whole square, which on simplifying gives us square root of 9 plus 16 plus 9, that is equal to square root of 34. Same way, the length of median CF can be calculated as square root of 6 minus 0 whole square plus 0 minus 2 whole square plus 0 minus 3 whole square, which gives us square root of 36 plus 4 plus 9, that is equal to 7. Now, we have an example here. Given that P 3 comma 2 comma minus 4, Q 5 comma 4 comma minus 6 and R 9 comma 8 comma minus 10 are collinear, find the ratio in which Q divides PR. Look into the solution here. Suppose Q divides PR in the ratio k is to 1, then coordinates of Q are given by 9k plus 3 upon k plus 1, comma 8k plus 2 upon k plus 1, comma minus 10k minus 4 upon k plus 1. But coordinates of Q are 5, 4, minus 6. Therefore, they can be equated as 9k plus 3 upon k plus 1 is equal to 5, 8k plus 2 upon k plus 1 is equal to 4 and minus 10 minus 4 upon k plus 1 is equal to 6. These three equations give k is equal to 1 upon 2. So, Q divides PR in the ratio 1 upon 2 is to 1 or 1 is to 2. Another example here, a point R with x coordinate 4 lies on the line segment joining the points P 2, minus 3, 4 and Q 8, 0, 10. Find the coordinates of the point R. Suppose R divides PQ in the ratio k is to 1, then the coordinates of R are given by 8k plus 2 upon k plus 1, minus 3 upon k plus 1 and 10k plus 4 upon k plus 1. Since x coordinate of R is 4, we can equate the x coordinate 8k plus 2 upon k plus 1 is equal to 4, which on cross multiplication gives 8k plus 2 is equal to 4k plus 4. Now, collecting like terms, we have 8k minus 4k is equal to 4 minus 2, which on simplification gives us 4k is equal to 2 or k is equal to 1 upon 2. Look into one more example. Let P and Q be any two points. Find coordinates of the point R which divides PQ externally in the ratio 2 is to 1 and verify that Q is the midpoint of PR. Let the coordinates of the point be P x1, y1, z1 and Q x2, y2, z2. Then the coordinates of point R which divides PQ externally in the ratio 2 is to 1 are 2x2 minus x1 upon 2 minus 1, 2y2 minus y1 upon 2 minus 1, 2z2 minus z1 upon 2 minus 1, that is equal to 2x2 minus x1, 2y2 minus y1, 2z2 minus z1. The coordinates of the midpoint of PR are x1 plus 2x2 minus x1 upon 2, 2y2 minus y1 plus y1 upon 2, 2z2 minus z1 plus z1 upon 2. That can be simplified as x2, y2, z2. Clearly, these are the coordinates of point Q. Hence, Q is the midpoint of PR. So, let us summarize the chapter of 3-dimensional coordinate geometry as in 3 dimensions, the coordinate axis of a rectangular Cartesian coordinate system are 3 mutually perpendicular lines. These axes are called the x, y and z axis. The 3 planes determined by the pair of axes are the coordinate planes. These planes are called xy, yz and zx planes and they divide the space into 8 regions known as octants. The coordinates of a point P in the space are the perpendicular distances from P on 3 mutually perpendicular coordinate planes yz, zx and xy respectively. The coordinates of a point P are written in the form of triplet like x, y, z. The coordinates of a point are also the distances from the origin of the feet of the perpendicular from the point on the respective coordinate axis. The coordinates of any point on x axis are of the form x, 0, 0. The coordinates of any point similarly on y axis can be in the form 0, y, 0. On z axis it will be in the form 0, 0, z, and the coordinates of any point on xy plane are of the form x, y, 0. Similarly, the coordinates of any point on yz plane are of the form 0, y, z, and the coordinates of any point on zx plane are of the form x, 0, z. Also, the distances between two points P x1, y1, z1 and Q x2, y2, z2 is given by the formula PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. The distance of a point P x, y, z from the origin O, that is 0, 0, 0 is given by the formula OP is equal to square root of x square plus y square plus z square. The coordinates of a point R which divides the line segment joining two points, namely P x1, y1, z1 and Q x2, y2, z2 internally and externally in the ratio m is to n are given by the formulae m x2 plus n x1 upon m plus n, m y2 plus n y1 upon m plus n, m z2 plus n z1 upon m plus n and m x2 minus n x1 upon m minus n, m y2 minus n y1 upon m minus n, m z2 minus n z1 upon m minus n. The coordinates of the midpoint of the line segment joining two points x1, y1, z1 and x2, y2, z2 are given by x1 plus x2 upon 2, y1 plus y2 upon 2, z1 plus z2 upon 2, and the coordinates of the centroid of the triangle whose vertices are x1, y1, z1, x2, y2, z2 and x3, y3, z3 are given by x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3, z1 plus z2 plus z3 upon 3. So, students, hope you enjoyed studying the chapter 3-dimensional space, location of a point in 3-dimensional space and the distance formula with the section formula. Thank you.